welcome back. I am so excited to introduce the next speakers. Please join me in welcoming Daria and James from Key Insurance.
Hello.
Hi, everyone, and thank you for being here with us for the headliner act of today. Let us introduce ourselves first.
Yeah, so hi, everyone. My name's James D'Souza. I'm a staff engineer in our algorithm engineering team at Key Insurance. So algorithm engineering at Key is kind of halfway between software engineering and data science, kind of somewhere on that spectrum. Prior to working at Key, I had kind of a weird background. So I started off as did a physics degree. I did accounting for a little while, gradually kind of moved my way into tech, and then, yeah, I've ended up at Key, where I've been for the last 4.5, 5 years. So yeah, that's me, Daria.
Hi, I'm Daria. Unpronounceable last name, don't worry about it. I am a staff data scientist at Key. I also had a pretty weird career. I actually started in risk management and financial markets. I then was in a hedge fund for a few years, which is where I got into research. And then data science started ramping up, and I was like, wow, that is really exciting. So I moved over, was in a couple of financial insurance startups, randomly spent 3 years in the music industry, did all kinds of things, and then, hey, guys, I really miss a regulated financial industry, and this is how I came back to Key Insurance.
Cool.
So what are we going to tell you about today? All our journey. Both James and I have been here since the beginning, when Key started. And we went from nothing to over 1 billion of premium today in a market that's very traditional. It was not easy. We'll tell you exactly how not easy it was, and we'll also tell you what data science had to do with it.
Perfect. So before we get into kind of the juicy details of all the good data science stuff, just try and set the scene a bit. So we're going to talk a bit about the market that we operate in, and kind of like what the problem is that we're trying to solve. So just before getting into that, can I do a quick show of hands of how many people have heard of Lloyd's of London? Okay, wow. Good number who've heard of Lloyd's of London, good stuff. How many people know how the kind of syndicated market works in Lloyd's? Handful, Jags, nice. Cool, few of you, mostly from Key. So, so Lloyd's was established in 1689, so it's been around for a really, really, really long time. Just for context, that's about 100 years before the USA was founded, I think, if I've got my facts right. So it's been around for a really, really, really long time. It started off as a little coffee house in the city of London where people came to insure ships, and it's kind of ballooned from there. Sort of one of the interesting facts that I found out recently is people used to come and put the name of their ships up on the wall in the coffee shop, and then people would come and write their names underneath the ships, and that became known as underwriting, and that was sort of like the most rudimentary form of insurance contract, and that's where the word underwriting comes from. So Lloyd just kind of turned into this massive player in the global insurance market. It's kind of carved out a niche in really, really, really complex specialist pieces of insurance. So the types of things that get insured through Lloyd's are, we've got things like insurance against big natural disasters. So hurricanes are something that tends to get insured through Lloyd's. Things like big shipping containers. So there might be like hundreds of millions of dollars worth of goods going through shipping containers. And then luckily for everyone in here, I couldn't find a Creative Commons licensed picture of this, but Tom Jones insured his chest hair through Lloyd's of London. So all sorts of weird and wonderful things, but it tends to be like really, really, really big corporations insuring like big things. So going to go a little bit into sort of how the market works. So Lloyd's is essentially an insurance marketplace. So we've got clients. So say there's a big company, somebody like a large soft drinks insurer, and they might want to come and insure like all of their factories. So that's going to be like multinational, global kind of piece of insurance. It's going to be really, really, really complicated. You might have things like business interruption insurance in there, so you need to understand what the kind of knock-on impact of one of these factories not functioning for a while is. You might have complex like supply chains in there. So essentially what I'm trying to say is it's like really, really, really complex pieces of insurance. A client will go and speak to a broker. A broker will basically work with that client to understand what exactly do they need, how do they need that to work, and then a broker will come and speak to an insurer to actually like understand, okay, how much is that piece of insurance going to cost? What are the terms need to be in order for this to work? And the contract is ultimately signed between a client and an insurer. Going to zoom a little bit in to that broker-insurer relationship because it's not quite as simple as that one-to-one kind of thing that was on the last slide. So what tends to happen with these risks is that they're essentially like massive pieces of insurance, and a broker will come and speak to a load of insurers. They'll work out how much this thing's going to cost. They'll work out what the terms are, but what we know as a lead insurer might say, I only want to take on 30% of that risk. So they might not want to take on the entire thing because it's basically too big for that company to take on. What then happens is that a broker goes and speaks to what we call follow insurers. And now follow insurers, they're not going to be setting the terms of the policy. They're not going to be saying how much that policy costs, but they are going to be doing what we call deciding on a line size. So that's this thing in the bottom left corner on the slide here. That's basically how much of a policy they want to take on. So a broker's job at this point is essentially to kind of fill up from 0 to 100% this policy to make sure that it's fully covered. Just a little bit of jargon in case we fall into that because we're just too used to jargon in insurance. So line sizes are these percentages. That's going to come up a little bit later on. And then a contract is often referred to as a slip. I have no idea why that's the case, but it is. So then, yeah, a broker will go and speak to lots of different follow insurers to basically fill this slip up. It's generally a really, really manual process.
Yeah, and that's where Key Insurance comes in. So we are the follow syndicate. And what's new then? There's over 200 of syndicates overall in the Lloyd's of London market. Most of them do follow as well. Well, so because the market is so old and so complex, the risks are so idiosyncratic, it's still to this day a very much face-to-face, person-driven business. People do come, talk to each other. Deals are done through paper stacks and terrifying amounts of emails over weeks. So that's where Key saw an opportunity. We are the first, and as far as I know, still the only one, end-to-end, digital syndicate in the Lloyd's of London. And not only we're trying to do things digitally, we are also employing algorithms to proxy the decisions that's normally a very much human expert-driven decisions that are going on.
Yeah. So what did we actually do to try and solve this? Essentially, we built a website. It looks a little bit like this, where brokers could come to our platform and they could type in a load of information about this risk. They would get back a quote from us. So we would decide on a line size within a couple of seconds. So the idea is that we're taking this process from weeks of negotiations and discussions with people, cutting that down to 5 minutes of filling out a form, and then a couple of seconds to receive a quote. So going to really quickly run through the kind of history of Key. So Key started back in 2020. Daria and I, as I say, joined towards the end of 2020, sort of October, November time. At this point, Key had partnered with a couple of companies. So we partnered with Google, we partnered with UCL, University College London, and we partnered with a big Lloyd syndicate called Brit Insurance to basically like kickstart the process of creating this insurance syndicate. And then we also got funding from Blackstone. So Key's got $500 million of funding from Blackstone. So over the course of the last 5 or so years, it's gone from, this sort of like zero revenue little company to, I think, last year we just did just over $1 billion worth of premium. And we've grown from, I think when we joined, like 10, 15 people up to about 400 people. So it's been a massive growth over that time. So what we're going to try and do is transport you back to around 2020 and just talk you through like how we went through that process of going from zero up to where we are now. So as I say, we joined, there'd been these partnerships. Our job was to kind of work out, okay, how do these models that have been built work, and what can we do to make them better? How can we actually go and improve these things? So we did what any London-based startup does, which is to book a room at Shoreditch House and to go and do some workshops. Pro tip for any budding founders, make sure you take some pictures of these workshops. We were trying to find some, couldn't find some, so all we've got is a map. So what we ended up with at the end of this was kind of figuring out that our job here was to kind of try and assess risk accurately, even though we had imperfect data, I think, to say the least. We'll talk about that a bit more in a second. We needed to come up with an optimal line size for each of these quotes that we're doing. We need to try and maintain a balanced portfolio across our book, so we want to make sure that we're not over-investing our insurance into specific areas. We need to make sure we've got a diversified book, and then we need to try and do this all in real time without any human intervention, so that experience through the website is as seamless as possible. So yeah, we're going to go into talking through what we kind of came up with in order to do that. So over to Daria.
Yes, so let's talk about something that we affectionately refer to just as the algorithm and key. When we started trying to solve the problems that James just outlined, we looked for inspiration everywhere, really blank slate. We first looked at the specialty industry itself, but then we realized, hey, you know what, we're here to disrupt. That was the task given, so maybe not. Maybe we're not going to repeat what's already been done. We fell back to maybe our previous work experiences, finance, physics, everything was an option. We even thought about, hey, does autonomous driving vehicles model apply here, possibly, maybe. But in the end, we settled at something actually much simpler than this. So when the broker comes to the platform and presses that get a quote button, what then happens is all the information goes into the step one, which is called the risk assessment models. The goal of this part of the algorithm is to essentially understand, from our point of view, how would we predict, is this risk attractive or not attractive from the point of, is it going to give us more premium than the loss that is going to have to pay out? So ultimately, all the information, the properties of the risk go into that prediction of a potential claim. That information then goes to the second step of the algorithm, which is the digital portfolio management. Now, we know that about one risk at a time, but we actually have already written a whole portfolio. We also have an idea of what the ideal portfolio we actually want to hold looks like, and all the constraints, all kind of possible guardrails around it, our risk appetite, our opinions about the market, and so all that being taken into account, and that risk properties that we're seeing, how much of that line size do we want to take? So that's the decision that then the digital portfolio management bit does. And then it goes back all the way to the platform, to the broker, as our commitment, you can take us up on this much on this policy. So this is what it does, and remarkably it does it under, on average, 7 seconds for any risk. And just to put it in contrast with what happens in the market today, in pretty much all the other syndicates, it's about 2-3 weeks process. The underwriters will have to physically go to the Lloyd's of London to a room called a box. They have to talk the terms, they have to sign the physical papers. A couple of weeks of emails with spreadsheet attachments and modeling there. A couple steak lunches in between just to shake on the deal, and that's how long it takes. So really Key saw a big opportunity here to be more scalable, need less people to do the same amount of decisions, and also do those decisions well and robust, so that in the end of the day, we actually have a profitable portfolio. And doing things digitally, end-to-end, does not mean there was no human oversight, no human involvement, but we still wanted, particularly in the early days, pretty tight guardrails of what the algorithm could do while we were proving what it can do. And then as we gained credibility, we were slowly relaxing those. So this is the algorithm. Let's dive into the first part of it, the risk assessment models. Ooh, boy, if you ask me today, if I'm going to go and do this all over again, I'd probably give it a longer thought than I originally did. It is not an easy market for supervised machine learning. Let me give you 4 categories, roughly, of all the problems that we actually had to deal with. Well, first of all, big one, we do not have a lot of data. Imagine it's a 2-3 week process for one risk. And you have maybe 20 underwriters. Underwriters are expensive specialists, and there's only that many clients and your volume of the market. So let's say optimistically you manage to do a couple thousand of policies a year. Maybe you go back 10, 15 years history of what you have seen. But that's still far away from big data, particularly comparing to how similar problems might be tackled in financial markets, where it's milliseconds of data availability. Completely different. The other thing is the skew in the data. Luckily for the world, but not very good for supervised learning, there's not many claim examples. But we exactly need to do that. We need to link the properties of the risk we're seeing to the outcome of whether there was a claim or not. That's not really good when we only have a handful, a dozen of examples of the claim ever happening. The other thing is every syndicate is super protective of what policies they're writing. You know your book. You hopefully know it well, but you don't see what others are writing. It's a very well-guarded secret. So really, you only see a proportion of that market, and it might not be that representative of the whole. And there are just so many different types of risk. He writes at least 30, from director's liability to cargo ships to Taylor Swift concerts. You really have to model each of them separately, and it's a very different nature of risk. The other thing that really exists here in the market is it takes a long time sometimes for claim to realize. You can write a policy, let's say it's director's liability. They can do something wrong, but no one knows about it. Their career moves on, they move somewhere else, suddenly something comes to light. Then there's years of litigation until you actually settle on an amount of how much of the claim you have to pay. So it could easily be 12, 15 years until you actually realize the claim. And for the supervised learning, well, the nature of the risk might have already moved on in that decade. So how useful is it even at this point for the model? And just to top it up, data availability and quality. We had to deal with a lot of effort to just pull the data out into structured format because largely it exists in very unstructured now. PDF, Excel files at best. We really had to pull data from handwritten notes. And that was pre-LLM, lots of fun. So what did we do? We threw quite a lot of the usual suspect solutions that ML normally employs to deal with this kind of problem. But really what also helped quite a lot is to actually simplify on what we did as our first approach. Go simple, give a very low benchmark to prove it works, and then iterate from there and see where does it make sense to actually add complexity. So what did we do? We narrowed down the problem to actually predicting the probability of a claim. So not the full amount, but just really, is this policy going to have at least one claim or not? And what's the likelihood of that? That allowed us to make this a classification problem. It was much easier to do compared to regression on the low data, but also it was still as beneficial for the business purposes because what that gave us still is the ranked list of policies from least likely to claim to most likely to claim. And then we tested if we go with that prediction, do we get a more profitable portfolio than a very easy benchmark like a random guess on how risky something is or a flat risk assessment? And it worked. So that was great. We also limited it to a very broad but common set of features for different policies and just looked at the data that we already had. And because we were, one, quite ignorant of what actually is traditionally happening in the market as the methods, and two, like very cowboyish ML, we mostly used supervised machine learning for our data here. So this was our first iteration. It worked nicely. We were all happy with it. And then what we did is we then followed the particular policies that we write, which had more data, slightly more data, and also a big business need where we could let these models show exactly and shine how to select risk more profitably. So we started building the complexity. And this is where we're today. What we did is, where it made commercial sense, we went and bought third-party data. We also went from this broad policy level to individual asset level. For example, if it's a big multinational company that needs to insure all its factories in different countries in the world, instead of just seeing one line item for that company, we're now seeing all those hundreds of buildings underneath. And if we don't have already in our books the information about a certain building, if we've never insured it before, what we did is we actually used some APIs to geocode it, then look at a satellite image where that building is, extract from the image all the properties of the building, then put it through the model to understand the risk. So I think it's actually pretty cool, as cool as it gets. And then, once we've done all of that cool stuff, we did actually run out of steam, or rather data, and eventually we were left over with a bunch of types of risks where the problems that I've outlined previously were just way too severe. There was no way we could oversample that or do whatever else to actually get enough data to then say, okay, we can have faith in this model, put it in front of people to make decisions on the risk. So we started embracing the wisdom of the traditional methods used in actuarial science. A lot of them use the human expertise and experience to actually come up a priori with the factors that drive the risk, and that way predict by exposure to those factors. And actually what we do today is every new model that we're doing, and we still have ways to go, we do it straight away with actuaries, and we've created this whole system where we collaborate from day one, where we look at the data, and if there are pockets of data-rich part, we use machine learning. If not, then we default to the factor-based class, and it started working very swimmingly. What it also allowed us to do is actually start speaking even more of the same language as the rest of the market, despite using newer methods. We actually also produce richer outputs that are closer to how traditionally actuaries look at the risk. We started down predicting the actual dollar loss value. And not only that, not just one point estimate of it, we give the distribution around it, and we also give a confidence score of how much faith do we have in any of those numbers. And then all of that goes into the next stage of the algorithm. But before I give it over to James to speak about it, one more problem that was a big problem that does not relate to data, but it is, how do we take stakeholders on the journey with us? And we have to constantly answer those questions. At the end of the day, the algorithm proxies the decision-making that a human underwriter would normally do. So it's vitally important for us to actually take them on the journey so they understand what's happening in the model at any point in time and agree with it and can have credibility in it. But some of our stakeholders and the underwriters love this technical stuff. Not everybody does. And then also, the natures of the risk that we insure are so multidimensional, and then it so happens that those dimensions are more likely than not categorical variables. When you start stacking them more than 2, 3 together, you can get very quickly lost in all the traditional ML graphs that you're trying to explain your models with. So we're increasingly started using more example-based explainability methods to actually create a narrative around it. In here on the slide, you can read, this is the buildings, and the buildings that actually taught the model out of the training sample, so that we can actually tell those were influential on the current prediction that you're seeing. And it worked. So yeah, we actually got a really good response when using this kind of language and this type of methods. So there you go. Over to you, James.
Perfect. Thank you. So yeah, I'm going to talk a little bit about the second part of the algorithm, which is this digital portfolio management bit. As you can see at the end, this is what's determining that line size that I was talking about a little bit earlier. So on this, we kind of started off incredibly simply, like almost embarrassingly simply. But this kind of really helped us get going and just got something up and running as soon as possible. I think that's something that we try and do all the time, is do something easy and then iterate on it as and when needed. So essentially what we did for each different type of insurance was, if you just set a minimum and a maximum line size that you want to do, and then we scaled linearly between those two numbers. So here, for example, you've got a sort of middling risk assessment score, which has come out of the process Daria was just talking about. And that's going to give us this $7.5 million line size. So we've got a minimum of 5, maximum of 10, just like a linear scale between that. So as I say, that was great. It got us started, but obviously it's not particularly clever, and it kind of has massive limitations. So big limitations that had to start with were, A, it didn't give us really any tools to manage our portfolio with. So you're kind of you're kind of just waiting for whatever a broker brings along to our platform, and then we kind of write that. And then the second thing is that it doesn't really let us manage our aggregate risk properly. So first thing that we did, there were two things that we did. The first one was that we kind of built this ability to set different sort of levels of risk appetite. So here you can see we've got a low, medium, and a high risk appetite. These essentially just let us set different minimums and maximums. This obviously results in different line sizes coming out of the process for the same risk assessment. So this is pretty straightforward. It's not like rocket science, but what it did allow us to do was get some of the sort of industry knowledge from some of the experts that we had in other parts of the company and like embed that into our live systems. And then another thing that we did, which was actually quite nice here, was that we built a user interface around this, which let some of our sort of less technical underwriting folks go and interact with this. We could react really quickly, make changes really quickly. So if there was a big change in the market, somebody could just come into this, type some things in, and it would kind of automatically change our live algorithm. The second thing that we did was start looking into how we manage our aggregations in an automated way. So this example that I've got up here is what we refer to as wind gates. So they're these kind of little colored blocks that you see around the coast of America. They're essentially like areas that are at high risk of something like a hurricane hitting, and you could get floods following that as well. What we basically did here was for each of these, we wanted to measure how much exposure do we have to each one. So what happened if a hurricane came through one of these areas? And then we basically set a target for each of these so that we could say, as we kind of get close to that target number, we want to start tapering down the line sizes that we put out to avoid ourselves from getting too overexposed. So there's a couple of interesting technical challenges in here. One of them was like a sort of pure engineering, data engineering type challenge of how can we, in a couple of seconds, manage to extract that information? So we might be looking at a couple of hundred, even thousands of properties. How can we extract all of that information, geocode it, put it into these areas, and kind of understand like how that's going to affect our exposure? So that was engineering challenge number one. And then the second challenge was about setting these the sort of targets that I was talking about. So what we wanted to do was set those targets in such a way that we could keep writing profitable business, but make sure that we avoided overexposing ourselves and avoided any like really, really, really bad things from happening. Would love to spend some more time talking about that, but we don't really have time to go through the details of those things. So come and ask us afterwards if you're interested. I guess like things that we're kind of looking at working on at the moment and into the future is taking a lot more of that kind of portfolio management optimization kind of techniques and applying those to insurance. So we're looking at sort of portfolio management theory, that kind of thing, borrowing a lot from the sort of world of finance. There's a couple of interesting challenges that we have, so that are sort of pretty specific to I think, to insurance and how we do insurance. So number one is that we're making decisions sequentially. So we only ever see one risk at a time. We don't have like a bucket of things to decide on at any given time. So we're looking at individual things, seeing how they're going to affect our portfolio and trying to make a decision on that. We don't know what we're going to see later on in the year. So you ideally want to make decisions now based on what you know is coming up in the future, because that's all going to affect your aggregate kind of position. If you know something in the future is going to come up that's a really profitable piece of business, you don't want to fill up your wind gate from the previous slide in that area. And then the third one is that users kind of expect an answer from us in seconds rather than being able to run any like long, complex optimizers. So these are all kind of challenges that we're working on at the moment. There's a lot of interesting things that we're doing in here. Hopefully I'll be back in like a couple of years to talk about how these things have gone and sort of how we've managed to solve some of these challenges. So, on to the wrap-up.
Yeah, to conclude. We actually went with the very first iteration in under 6 months, and we have been writing $1 billion of premium now, scaled up pretty quickly. We're also doing it profitably, and we're actually doing it in a super traditional market, so well done us. What did we learn? A huge ton. One, to be humble when working with other disciplines. Did we achieve a good result when we used the pure ML approach? Yeah. Did we make an even richer, better models when we embraced all the traditional actuarial methods? Also yes. And it helped us build the credibility, the iteration, and going back to speak the language of the industry where we started in, all helped to actually iterate and build complexity. We want to do more of the same. We want to continue doing more models, make them faster, make them even more reliable. We want to do it without compromising on how easy can we explain it. And there is a tons of application for ML and data science in specialty insurance beyond just the risk assessment models, which we are starting to explore now at Key. We are hiring. Please do come see us. Please talk to us if you want to ask any further questions on what we talked about today. Otherwise, thank you so much. And we have our details here on the slides if you want to keep in touch, or come see us at the drinks. Thanks for your attention.
Fantastic.
Perfect. Yeah. And we've got time, time for questions.
Questions as well. I mean, questions, drinks, yeah.
Hi, thank you for this great talk. I didn't know that somebody can make insurance sound fascinating, actually.
Yes.
I think you addressed this question, but I just want to make sure because you're dealing with underwriters who are known, to have their own opinions and have different results. Daniel Kahneman in his book Noise talked about it. Mm-hmm. We work with surgeons, and we give the surgeon an X-ray, and they'll have different opinions. So now that you have an algorithm, that dictates. Great, so that reduces the noise. But to create the algorithm, you trained it based on other people's opinions, which are diverse. How did you overcome that challenge?
Well, one of the positioning of the algorithm is to make it more objective. So we do have this whole process where we work with stakeholders. We want to give them the whole guts of the model, make sure they agree with it roughly. They don't always do, as you said. There is multitude of opinions.
But you didn't base it on their opinions?
If we can be data-driven and we are confident in the model, we would rather push for the model's opinion rather than underwriter's opinion. But at the end of the day, there's no easy answer. It's a careful dance. We are working with individuals. We do need their buy-in as well. And also, we know the limitations of the data-driven method is that it can't predict something very emerging, and the risks are emerging all the time in the market. So it's a delicate balance of the model-driven opinions together with an overlay through things like dials, for example, of the underwriter opinion. And then we also try and attribute how well do each of those do in the monitoring process and looking at the performance of any of those decisions being made. And that is literally just about building then the backlog, the backtest, if you want, of what worked, what didn't work, and then mutually learn over it.
So it's not the simple case of like classical data science in which you have your x's, you have your y's by the target variable by the underwriter, and they normally would be noisy and wouldn't agree. So you didn't base your machine learning model based on that sort of data.
No, as much data driven as possible, and opinion is the second like line of defense, let's say. Yeah. Second line of defense is the opinion. So like in those places where there's just not that much data to go on historically, we know the model would not be as reliable as well. We might give more weight than to human opinion, who's an expert.
So the ground truth is the algorithm, that's the ground truth?
The claims data from like historical years. So we worked with Brit Insurance. They had, I don't know how many years of claims data from similar kinds of risks. So that was kind of like the ground truth data that's used for the models.
So the algorithm, by the sounds of it, at some stage of it, kind of mimics the actuary's opinions, so basically human decision making. While discussing all this with your stakeholders, do they ever feel threatened by it? Because to an extent, now in the world of AI, we all kind of feel a little bit uneasy at the back of our heads that, AI will replace us. But you probably got there first, right? So have you ever come across this problem or anything kind of looking like this problem?
So your question is whether did we get like pushback?
Yeah, pushback. I know better. I've been doing this for 30 years, blah, 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 blah.
So I think we strategically hired from people who were agreeing in the first place that we can do this scalably. So the underwriters that are our internal stakeholders that are working within Key are sort of primed in a way to actually give the algorithm a chance. At the same time, you're right, but we had very funny stories. Like, for example, one underwriter gave us an idea of what feature we could add to the model. It so happened we already had the component data, just not the feature engineered itself. So we quickly engineered it. And what happened is that the underwriter's opinion was already 100% picked up by the model. Whatever he said was more risky based on that feature we just engineered was already perceived inside the model as more risky. And if anything, that was a win-win for the models and for the underwriter. He felt listened to. We also reassured him the model already implicitly picked up on that. So stories like this helped us to build more credibility and stuff. But then adoption of the platform itself and how do we get brokers to come and actually use it, that's probably where the biggest industry pushback was. If I can call it pushback, but clearly there is demand. But there you go. I would say it's brokers who needed the whole sales process. Yeah.
Hello. Hi. I think at some point you described you're using something like a cross-sectional model, a factor model. I was wondering how much risk, can you explain with that, how much remains idiosyncratic? That makes sense?
So your question is about factor models and how we use them. So there's a multitude of different models used in actuarial science. I'm not an actuary. I am still learning all those things. But the way I know at top level is they predetermine the set of factors that they know influence the risk. They also, either from historical data or their opinions or some kind of interpolation or a combination of all of those, come up with a sensitivity of each of the factor to total risk. And then once the risk comes in, you calculate your exposure to those factors and then sort of multiply, sum up, and get your total loss prediction. So that's what we refer to as the factor models in actuarial science.
Yeah, thank you for I think that's a really interesting introduction to Lloyd's. I think having been to Lloyd's and seeing the box, I feel like it's really cool what you're doing, obviously modernizing a very old industry, very resistant to change as well. So I'm quite curious, I think you mentioned that it's from the sounds of it, obviously using this platform / technology, it's underwriting will be way faster, generally speaking. But what I'm curious about, do you see with your algorithmic approach, is it reflected in a better combined operating ratio then, compared to your competitors? You see an advantage financially, not just...
Yeah. Yeah. I think so far our combined operating, so our underwriting performance has been sort of roughly in line with competitors, and then where we kind of think that we'll be able to, sort of in the short term, where we think we'll be able to do better than them is in the expense ratio part. So rather than having lots of people, I guess it's like everything that we build now, we can continue building on top of, whereas when you have underwriting teams and individual people, that kind of knowledge lives with those people. So expense ratio-wise, we think we can outperform in the sort of shorter term. And then I think longer term, we do believe that we can get a benefit from the, in terms of actual underwriting ability from the model kind of data-driven approach. I think there's enough data out there about these risks that we're insuring that we can do that, and I think that there is enough out there so that we can actually get an advantage in that area. I think that'll probably come over the next few years, as we kind of make these better and better, and as we kind of get the ability to sort of test them in the wild much more. I think that, there's like a little bit of a kind of corollary to like the financial world back when sort of algorithmic trading first started. I think that's kind of how I see it in my head. Like, it'll take a while, but we will get there.
Thank you. And sorry, can I just follow up on, from the sounds of it, your approach means that it really excels in areas where there's limited data, right? So have you thought about expanding to is there any classes of risk or product lines that you're thinking of expanding to?
Yeah, it's a good question. We already have like a really broad set of different types of insurance that we write. So we do most of the types of business that Lloyd's writes, and I think what we're really trying to do at the moment is focus in on the ones that we're really good at and kind of make sure that we're getting those as good as possible. So it's almost like, I think right now it's almost like the sort of, like focus on the stuff that we can do really well, make that really good, and then we'll expand out once we've kind of got to that point. So I think maybe at some point, but we already write like a really, really, really broad book of insurance at the moment.
Thank you.
Cool. All right.
All right.
And I think related to your previous question and also to the nature of business where the claims can come 12, 15 years from the underwriting, how do you actually try to balance the portfolio, right? Because you can be writing like good business for a while, but then some new kind of risks comes in undetected and slips into the portfolio, and that can really sort of damage the picture. Mm-hmm. How do you actually balance this whole thing?
Yeah, that's a good question. We're kind of doing things like that sort of Windgate example that I was showing is something that we're trying to do and trying to do more of that kind of thing. I think there's a few different channels that we use for trying to balance the portfolio. So one of them is we still have like really close like ties to all of the brokers who we work with. So we will often go and speak to the brokers and kind of be like, you're giving us a really unbalanced book, please help us out. It's kind of like a help us help you out, because everyone is interested in sort of the overall market being well balanced and kind of well set up from that perspective. I think we're looking into a lot of what I think could be really interesting things around portfolio management kind of world. So as I say, like borrowing off of like optimization problems and being able to, I think what you'd ideally look at the sort of tail portion of your entire portfolio. So you'd get kind of a probability distribution of the entire portfolio and look at how can we make sure that tail doesn't grow too far. So it's sort of what would happen in the like worst of the, like what's the worst possible outcome for us essentially, and trying to limit that. We're looking into some really interesting things with, I don't know if anyone is like familiar with catastrophe modeling is something that a lot of insurance companies do, but there's a lot of things that we're kind of trying to borrow from the cat modeling world and see what we can do with those in sort of 10 seconds or so. So yeah, I think, I don't know if that like answered your question, but yeah, there's things that we can do with brokers. We can use some of these manual controls that I was talking about earlier, so just having like good monitoring and then being able to react to things. And then some of the more future-looking stuff is this like portfolio optimization, borrow from like catastrophe modeling type approaches as well. Cool.
Hi, you mentioned about not sort of filling up or not wanting to fill up your capacity, for want of the better word. Sorry, I don't know the proper term. In terms of, like not wanting to miss out on a really profitable piece of business and the kind of unforeseeability of the future. And I just wondered what your strategy was for tackling that.
Yeah, that's a good question. We've been looking into building a kind of like a sort of back testing engine. We call it our simulation kind of framework. What we've been looking at recently is how can we use that sort of simulation engine to sort of have a some sort of prediction, obviously with a lot of error bars, on what we're going to be seeing into the future. So we'll often renew like a lot of our risk, or something like 60, 70% of our business is made up of renewals that we can kind of take a view of how many of those renewals are we going to see again next year. And then what we're doing through this simulations engine is basically trying to do things like, okay, if we apply a distribution of how we think those are going to change over time, so how many of those are we going to see again next year, like a lot of sort of randomizing over that. If we run like thousands, tens of thousands of versions of that, can we then get a bit of a picture of like what do we think we're likely to see over the next year given certain market conditions? So we'll kind of try and parameterize that to be like, okay, what does the market look like right now? Let's run as many of these simulations as we can and then try and work out like what does the sort of future look like of it.
That's it. And one step further from that as well, we did a project with Alan Turing Institute on market modeling using agent-based models. So what that could also do is use that to generate the scenarios of what happens when demand-supply changes. You know, profits go up or down for the whole market, inflation, et cetera, that all plays a big role. And so what we can do is do that bit of modeling to come up with the scenarios for this simulation. And that's how we try and predict what we might be seeing in the near future.
One question, if I may. I'm not sure if you've been to the first presentation in this room today. The presenter was from the utilities sector. Mm-hmm. What was mentioned is that utilities sector is the second last to catch up on the data science developments, and the last one is actually insurance. So why do you think insurance is the last one to catch up? What's stopping other syndicates from employing the same ML models to kind of achieve the same result as you are trying to do?
So I think it needs a very strong character and a lot of courage. I could probably say our CEO in high management has always been very driven. It largely has been their idea to start doing things digitally. We also got a blank slate. It was amazing. We first even just had to prove, is it even possible to do these things digitally? This is where James and I came along a year in. We're like, okay, seems to be possible. Let's now scale it up. Okay, we've somewhat scaled. Now let's do complexity. And it took every step of that way, took this uphill battles of where do we get more data? We sort of assumed it's there, then we realized it's not. Hire consultants to actually manually get it out into a structured format. Now, thankfully, there's LLM. But every step was just so many unforeseen things. And then, I guess, the mentality of the incumbent people in the market. You know, I think you probably will agree with me, all kinds of like technological IT transformations, however well-intended, they're normally quite painful. And it's always the people, the processes, the systems, the cost, right? All this is so massive and so rooted in the bigger underwriting companies. And when you are writing so much on the line, right, you have to pay the losses because people rely in the world on this as protection. You also have to somehow try to make money. It's a very delicate balance. It's close ratios of how much you make on any dollar. It's not that much. So it's probably the huge amount of legacy, the fear of stepping out of what actually works now, and the cost of doing this.
Yeah.
And we've been waiting for competition since we've launched, but we're still waiting.
Yeah. I was going to say just like on that, I think the cost is a massive factor, right? Like Key started off with $500 million of investment from Blackstone and Fairfax. And so like the barrier to new people getting into the industry is really high. Like you have to raise massive, you can't just do this off of like a seed investment. You need like big investment because you need so much capital to run an insurance company to be able to pay out. So I think that's the other thing. And just like, that's just a really difficult thing to do. So yeah.
Thanks, James and Daria, for your presentation. My question is, the cost or the code is directly linked to what the model predicts, and which is directly linked to what kind of data it is trained on or it is getting fed with. So how often are you required to update the models or the data behind it, because it would directly impact the code, and there could be various reasons, geopolitics, things getting changed, the weather, everything. So how often are you required to update the models for the same?
Very, very good question. So this is where actually working together with the subject matter experts in the company helps a lot, because the classes also differ. These classes as different types of business, they differ a lot by how fast or slow moving the nature of risk is. Sometimes you would know what the claim is, if there is any, in less than 2 years. Sometimes it takes forever. Sometimes there's constantly new emerging things, like in cyber insurance, for example. You can barely keep up with what evolves, right? And then our modeling team works together with underwriters to understand the nature of the class. It's actually quite sticky teams to enable that learning from each other. And so what we do then is all our model monitoring and making sure that it's predicting what it should be predicting close to than what is realized, and allows for the active control today, given what's happening of the portfolio. That's all done together. So they will come up then with the frequency for monitoring, but the frequency of how often do we want to update. So we look at the data drift and the model drift, and how does it commercially perform in the portfolio? Are the model decisions helping it be better? So all of this is monitored all the time, and then we take action if needed.
Yeah, there's things like the user interface that I was showing up earlier for sort of being able to change things is like another way that we can really quickly react to things without, like, you don't necessarily have to go and retrain a model in order to react to things, because we've kind of built a few of these guardrails. So I'm trying to think of an example, but there's been examples where like a new piece of legislation will come in and a market will change like literally overnight. And so we can use tools like that to be able to react to it without necessarily having to do a sort of full model change. And,
maybe like sanctions, for example.
Yeah, exactly.
Yeah.
So yeah, there's like there is a modeling element to it, but there's other things that we also do to try and manage that kind of risk as well.
Amazing. So thank you so much. Let's give it up for James and Daria. They did say they'll be downstairs, so if you have any questions during the networking. So thank you so much, team. Really great talk. We've now got a couple of minutes. We've just got everyone filtering in from the last talks. At 5 p.m., we're going to announce the winner of the prize. If you haven't entered the competition, maybe there's still time. I don't know. Just post on LinkedIn. Take a look at your booklets. Also, in your booklets, there's some other great events coming up as well. So take this time to quickly check your booklets, scan all the QR codes, and get registered for everything. And we'll wrap up in just a few moments.